Welcome back to our channel. So in the previous session we have seen the AVL trees, so in the introduction to AVL trees, and in today's session we will see the rotations involved in this AVL trees. Right, so there are two operations that can be performed on AVL trees. So before going to those operations, we will see the property of AVL tree. We will just recall the property of AVL tree. So AVL tree is a self-balancing binary search tree. So it should obey the property of binary search tree, as well as it should obey the balancing factors for every node. So here there will be a balancing factor which can be a value of either -1, 0 or 1. So we have to calculate this balancing factor for every node, and it should be one among these three values. So the balancing factor, the calculation of balancing factor is the height of left subtree minus height of right subtree. So for every node we have to calculate, and for every node the balancing factor should be either -1, 0 or 1. So that is the property of AVL tree. So in order to apply the operations, that means if you apply the insertion operation or a deletion operation, again if you insert any node, after inserting the node, again we have to calculate this balancing factor so that it should obey the property of both the binary search tree as well as the AVL tree. So it should not deviate from the property, right? So after insertion or deletion, right? So if it doesn't satisfy this AVL tree, I mean the property of AVL tree, that is called an imbalanced node. So that means if any node is having a balancing factor which is greater than 1 and less than -1, then that is called an imbalancing node. So for that imbalancing node, we have to balance the node by using a few rotations. Right? So first we have to apply the insertion or deletion, and then again we have to check for the property of AVL tree. If it violates the property of AVL tree, we have to convert it to as a balanced tree by using these rotations. See, there are mainly 4 rotations we can apply. The first one is if the node if the tree is like this, so now calculate the balancing factor for this every node for this tree. So for C, there are no left child and right child, so the balancing factor is 0. For B, there is a left child, so there is left subtree and there is no right subtree. So the height of left subtree is 1 and height of right subtree is 0, so that is equal to 1 minus 0, that is 1, and here 2 minus 0, that is equal to 2. So here the node A, it violates the AVL tree property because the balancing factor for A is 2, which is not in a range of -1, 0 or 1. So here this is called, so why it became, because after inserting C to the left of left subtree. So inserting a node on left of left subtree. So that's why this rotation is called LL rotation. So this is called LL rotation, left of left rotation, right? So hope you understood this one. Now we have to rotate towards the right. See, for this condition we have to rotate towards right. So in order to keep this tree as a balanced, we have to rotate it towards the right. So after rotation towards the right, we'll get B as a root node, A as a left, C as a left, A as a right side. Okay, so here if you apply again the AVL tree, if you calculate the balancing factor for C, it is a 0 because the height, the leaf node, A is a leaf node, and B, the height of left subtree is 1, the height of right subtree is 1. So 1 minus 1, which is equal to 0. So that means the values are in between minus 1, 0 and 1. So that's why this tree is a balanced tree. And this is not a balanced, this is an imbalanced tree, because the balancing factor of A is 2. So this is how we can apply for LL rotation, left rotation. Next, the second condition, second one, similarly right skewed. So previously we have seen the left skewed, now right skewed. Here also the same thing. So the value of the balancing factor of node C is 0. Balancing factor of node B is minus 1 because 0 minus 1, left tree minus right subtree. So minus 1. Here it is a minus 2. Again, the node A is having, it violates the AVL tree property. So here, how it becomes a right skew? Inserting a node on right of right subtree. That's why we call it as RR rotation. RR rotation. So in such case, we have to balance the tree by rotating on a left hand side. Rotating the tree on left hand side. So that's why after rotating we will get a B, A as a left side and C as a right side. So if you again apply the AVL tree, that means if you find the balancing factor for this one, it will be 0, 0 and obviously it will be 0. Right? So this is called RR rotation, right rotation. Next, if the situation is like this, A, B, C. So B is a left child for A, C is a right child for B. Now, what is the balancing factor for this one? It's a leaf node, so 0. For B, left is 0, right is 1, it will be minus 1. Next, right side, left side is 1 and 2, right side is 0. So 2 minus 0, 2. So here again, at node A it violates because node A is imbalanced, right? So now we have to balance it. So this can be done. So this happens when inserting a node on right of left subtree. Right of left subtree. Right? So this is called LR rotation. LR. Left subtree inserting a node at right. Left subtree inserting a node at right. So left subtree inserting node at right. So don't get confused. So inserting a node on right of left subtree. So that is called LR. Left subtree on right side. Right. So this can be balanced in 2 steps. In 2 steps. So first step, see, consider this one right? Where we have an imbalanced node, it is node at node A. So just ignore the root node, and from the next node you just rotate towards left. Rotate towards left. So after rotating towards left, what will be getting? So A, B, C, right? So this is the result we get after rotating the subtree towards the left. Okay, so that is the first step. So now this is the left skewed. So always in the left right rotation, after applying the first step, we'll get the left skewed tree. From the left skewed, in the step 2, what we have to do? So this is nothing but LL rotation. So after first step, we should not calculate the balancing factor, right? So this is a two-step process. LR rotation is a two-step process. So after the first step, we have to consider, we will get the left skewed tree. So this left skewed tree should be balanced. So by using the LL rotation. So previously we have seen that LL rotation. So here we have to rotate towards left, including the root item. So after rotation towards the right, we will get a C, B, A. So this is how we will get the result. So this one. So this is a condition where inserting a node on right side of left subtree. Right? So that's why we call it as an LR rotation, left subtree right side. So this process can be done, that means this imbalanced will be converted to the balanced in a two-step process. So first step, other than the root node, rotate all the remaining nodes towards the left side. Right? So first apply the left, then apply the rotation. Simple logic. So first apply the left and second apply the rotation. So simple logic, first rotate all the nodes except the root node. So then obviously we'll get the left skewed tree. And in the second step, this is the left skewed, we have seen the LL rotation. We have to apply the LL rotation. So once again I am saying that after the step 1 we should not calculate the balancing factor, because this is a two-step process. We have to complete the 2 steps and then only we have to calculate the balancing factor. Right? So left skewed tree, so we have to apply the rotation in the second process. So first step left, second step right. So right side rotation. So we'll get this one. So this is called LR rotation. Right? So similarly we have to go with the one more thing, that is see, there is a one more thing, A, B and C. So this is the next condition. So here we can see that the balancing factor for C is 0, for B is -1, for A is -2. Again, for at the node A it is imbalanced, right? So in such case this is also a two-step process. So here why we got this imbalance? After inserting the element towards left of right subtree. Left of right subtree. So this is called right subtree left side. Right subtree left side. So this is called RL rotation. So here also the same process. It's a two-step process. After completion of the first step, we should not calculate the balancing factor. So A, B, C. So what is the first step? What operation we have to perform in the first step? We have to perform the right operation, right? So that means we have to rotate towards the right side. So accept the root node. Accept the root node. Accept the root node, we have to apply the right operation. I mean rotation operation towards right. Right. So after applying the right, we get the right skewed tree. So one thing you have to remember, that always after the first step of RL rotation, we'll get the right skewed tree, and after the first step on LR rotation, we'll get the result as left subtree, right? Then so we got this one after the first step, and coming to the second step, see, consider this one, right? Consider this one. What we have to do in the second step, we have to apply the left rotation, including the root node, right? This we have to do. So after applying the left rotation, so this is nothing but RR rotation. So after applying this one, we'll get B, A as a left child, C as a right child. Now the balancing factor is 0 for all these things. So this is a balanced tree, right? So this is called a RL rotation. The first step, we have to rotate towards the right, except the root node, and the second step we'll get the right skewed tree. So we have to apply the RR rotation. RR rotation means we have to apply the left rotation, right? So this is how we can apply the rotations, and with the help of these rotations, we can have the imbalanced tree to the balanced tree after performing the insertion or a deletion. So that means after performing the insertion or a deletion, if there is any change in our AVL tree, that means if it violates the AVL tree property, then we have to apply these rotations and we have to reform the imbalanced tree to balanced tree, right? So see, rotations, first one is, we have seen LL rotation, which is a left skewed tree, and the second one we have seen RR rotation, which is right skewed tree. Third one LR rotation, on the left tree, right side, and the fourth one is RL rotation. Right. This is the different rotations we have seen, and these two will come under single rotations. So that means we will perform only one rotation, single rotation, and this is will perform double rotation, single rotation and a double rotation. So this is a two-step process. For the first step, we have to apply the we have to rotate towards the left, and the second step we have to rotate towards the right. Here in the first step we will rotate towards the right, second step we will rotate towards left. right? So in the LR, after the first step, we'll get the left skewed tree. In the RL, we'll get the result as right skewed tree, right? So this is how we have to apply the rotations in order to change the imbalanced condition to balanced condition, right? So if you are having any doubts regarding these rotations, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.